Yes. Welcome to tutorial 11. Yeah, Soundarya, your question.
I was going through the question of week 11, like the quiz, and there they asked the question of is a call graph in a call graph that do you have to follow an ordered sequence? So in the video lectures, the professor has said it is not important to follow ordering sequence. My doubt is in a directed acyclic graph, right? You do not have to follow the order when you are drawing it. Right? But let's say you have to go pick up someone using the taxi. He explained it using the taxi domain example, right? So there he was like pick up and then you have to navigate. When you are picking up a passenger, you first navigate to their location, then you pick them up. When you're dropping someone off, you navigate to where they're being dropped off and then you drop the person off. So it is ordered, right? So in the question, I'll just read out the question once. They are saying, give me a second.
It's week 11, right?
Yeah, in the week 11 question, they are saying state true false. The ordering of the above call graph is important and subtasks should be performed via these orderings.
Which
So the
question is it?
it's question number 5.
Ordering of the above call graph is important and subtasks should be performed by this orderings. So for this particular call graph, it could be important, right? I mean, it's not true for all the call graphs, but for this particular one, the question is asked, right?
Yes.
So what do you think for this particular
I,
one?
I was thinking it will be important, right? Because you cannot just pick someone up without knowing where they are. So you have to follow an order. But the professor in the video just I got a bit confused when he said ordering is not important. Is he talking about ordering as like the steps to be performed, layering, left to right ordering? That is where I got confused.
Okay, which lecture is it? Second or I think first, right? This week, Max Q lecture.
The value function decomposition lecture.
Okay.
I think what he meant was that specific graph he drew on the board, no? It
Yeah.
need not be followed in that order, but the relative ordering of things was important. Meaning, I think the drop off can only happen after you navigate or that kind of thing. So I think what he, at least that's what I thought of it. When he said that the order in that graph is not important, I thought the relative order was important, but the graph need not be followed as this is how you will traverse. Uh, but the relationship was important between the nodes of the graph. That's what I kind of that's how I thought of it.
Yeah, that was what I was thinking too until I just thought of what if it was not that, and that's why the entire like doubt sprung up.
Okay, so yeah, I also think what Nikhil is saying, that's correct. But I mean, I cannot say it very, I mean, I'm not very sure about this. But yeah, here that ordering of the tasks, that relations matter. So what you can do is, okay, I'll watch that lecture again, and meanwhile, what you can do, you can post a question in the forum, and after I go through the lecture, then I'll comment on it.
Okay, so
Uh, Okay, so any other questions? Fine. So uh, today we'll discuss the topics in week 10. This you told about week 11, I think. Yeah. So week 10 topics will be discussed. So you have seen that different definition of optimality. So first one is hierarchical optimality. Then we have seen recursive optimality. And what is another one?
I think flat.
Yeah, so yeah, I don't know why he has called it flat optimality because it has already a name, global optimal. So flat also fine. So I think flat that has come because you do not have any hierarchy. Then whatever optimality you attain is flat optimality. So which one is so global optimal is of course the say this is a reward maximization problem. So global optimal will be the highest one. So say that is G. So that will be the best reward you can get of a task. And what are the other things? What will be the relation between hierarchical optimality and recursive optimality?
I think recursive optimal is optimal in each individual subtask is optimal. Hierarchical is, I guess you have to follow a particular policy in each subtask, but that need not be optimal in each subtask.
Okay, so say you are given, actually, my question is bit vague. So you are given a task. If you are uh, asked to solve this task, then without anything given, you will solve it in an optimal way. You can solve it in an optimal way. So that is called global optimality. Yeah, global optimal solution or something. Now suppose you are given a task plus you are given a hierarchy. What does that mean? Uh, say you are asked to say there is a robot. Robot is asked to uh, fill a cup with water, and there are multiple sources of water, and the robot is asked to fill the cup with a particular water from a particular source. So it has to go to the source, bring that water, or first it has to go to the cup, and then it has to go to the source, fill the cup, then come back and keep it on the table. Or there could be another thing that is near the source, there is a cup held or some container held. The robot directly can go to the source, fill the container, bring it to the table, and pour the water. So in the second, so should I draw some diagram? I think that will be better. Fine. So this is a cup, and there are multiple sources of water. And near the source, there is one container for each. Now the robot is here. So one way it can do is it can go to the cup, and here is the table, say. Go to the cup, or cup is on the table. Go to the cup, fill the water, and come back. Another way it can do, so there is a, say these are 1 unit travel. So there are 3 units of travel. So this is path 1, say units, and there could be another way where it can go directly to the source, fill the container, and come back to the table. So in that case, there will be 2 units it has to travel. Now, if for the normal task, there is no okay, so say the hierarchy, we are deciding, someone is deciding the hierarchy. It doesn't know that there is a cup existing near the source. So it will ask the set the hierarchy, saying that you first have to go to the container, and then you have to go to the take the container, again you have to go to the source of the water. So that way it will set the hierarchy, and the hierarchical after setting this hierarchy, the optimal point will be not the global optimal, rather it will be less than global optimal, right? So hierarchical optimality comes into picture when you have set a hierarchy to your task. So it's not just the task plus a hierarchy, then you have got your hierarchical optimal. So now, is it clear why hierarchical optimality will be less than global optimal solution?
Yeah. You have to follow. You're forced to follow an hierarchy, whether it is necessary or not to the global optimality.
Yeah, right. So, and then comes recursive optimality. So, what is the relation between recursive optimality with other two?
So you have to be optimal in each subtask.
Yeah.
Each in the hierarchy, you have to respect the hierarchy as well as be optimal in each subtask in the hierarchy.
No,
So that is the
actually,
worst kind of.
you're no. So when you said uh, you're wrong, because when you said it has to respect the hierarchy, actually recursive optimality doesn't respect the hierarchy. Why?
Okay.
Because okay, so for that I need another example. I think yeah, this example was given in the lecture also. So that grid world thing. Bigger. So this is your goal state, and So here room 1 and room 2. So for learning, what hierarchy you can set is first you go out of room 1 and then you start with at room 1. So you first will go out of room 1 and then you go to the goal state in the room 2. So here we have hierarchy. And second is go to the goal state. So given this hierarchy, first we'll look at recursive optimal solution. So I'm considering continuous. I think in lecture it is considered as discrete. So first is draw a straight line from your origin. Say this is your origin, first initial point, and draw a straight line straight towards the nearest uh, room door. If you are above this dotted line, you will go to the first door, and if you are below the dotted line, then you go to the second door. So this is your recursive optimal solution for the first task. So when you are solving this, you do not have in mind that what you have to do after going to second. That's why it's arise. I mean, this is resulting some suboptimality because you don't know what you will do next. It's like myopic. You're not thinking ahead of time. So, and here for this setup, hierarchical optimal, when you are here, say your initial position is here, you know that what you have to do after going out from room 1. So what you'll do, you will not go this way, you'll not go this way. You know you have to go ultimately there. So you go here, and then from there you go. Okay, so here you have, if you see this example only, you will feel that probably hierarchical optimality is equals to global optimality, because that is the case here. But to understand the difference between hierarchical optimality and global optimality, you have to see this example, that water fetching or whatever. So here what we can write is H is greater than R. So hope this is clear. So now we'll discuss SMDP. So why SMDP is important in discussion of hierarchical RL? That's the most important thing. So I think professor has suggested a paper. I'm discussing directly from there. So the title of the paper is Recent Advances in Hierarchical Reinforcement Learning. There is another paper I have found.
Why did you
Yes.
say that recursive doesn't have to follow hierarchy?
So whenever you
recursive does have to follow hierarchy, right?
No, so
in this particular case, recursive had to follow the hierarchy, right? In the example you have shown.
Yeah, so
you have
it
to
will
go out
follow.
of room 1.
Okay, so there are two things. One is following the hierarchy, and another is
Being optimal.
yeah, no, keeping the hierarchy in mind while taking your initial actions as well. So yeah, it's following the hierarchy in the sense that it is asked to go out of the room one, it's going out of the room one. That's true. But it's not keeping in mind that what it has to do after going out of room one. So it's not seeing the hierarchy ahead of time, seeing the ultimate goal. Okay, so so uh, if you are asked to solve a problem in recursive optimal way, and if you give the agent two problem instances, in one it will the goal state is in the above in the top of the room two, and another in the bottom. So to go out of the room one, it will follow the same. I mean, irrespective of the situation, it will execute the same task, same policy, better to say. Okay. Then after coming to room two, it will start thinking where it has to go next. Okay. In that sense, it yeah, follow the doesn't follow the hierarchy might be a wrong word, uh, wrong comment to make, but it doesn't keep the hierarchy in mind while optimizing the problem. Is it clear? Hello? Hello? Am I audible? What is happening?
Yes, your voice is audible.
Okay. Is Nikhil disconnected?
Nikhil is muted, I think.
Okay.
Sorry, my internet went bad for a minute.
Oh, okay.
Yeah.
Is it clear?
Yeah. Your explanation I heard. Yeah,
Okay.
I uh, I understood. Basically, you don't see ahead. You
Yes.
don't really care. You just need to care. You care about what is at hand right now, and do that optimally.
Yeah.
Makes sense.
Okay. So there are two papers. One is recent advances in hierarchical reinforcement learning, which I think mentioned by professor. Then another paper I have found, which came much later, I think in 2002. Yeah. Title of the paper is Hierarchical Reinforcement Learning, a Survey and Open Research Challenges. So that paper is much more what Nikhil was saying in the beginning, that I we want to see something concrete, like more mathematical expressions, and not more, but I mean clear-cut mathematical expressions. What is happening? So I think this paper you can follow. The second one, what I have told, hierarchical reinforcement learning, a survey, and open research challenges.
Can you share the
I
link?
can. I don't have the link now, but I can post the name and the name of the authors. I mean title and. Yeah, so posted in the comment box, sorry, chat box. Yeah, so let me discuss some things from here. So, say your original task is a MDP, right? That's how we have read in our previous topics, and we have there was just plain article. So you have this SA, PER, and let's say we are only discussing about discounted setup. There is a discount factor. So first, let us define this policy and value and all. So pi stars say that's the policy, the optimal policy. Okay. And value function. Let me write the Bellman equation as well. Okay. So how this MDP evolves? Sorry, my voice is throat is getting choked. So starting from A0, we take action A0, go to state S1. So okay, so this is the normal flow of MDPs. And what in hierarchical RL we do is we see a state, say we are at the first state, say S0. Say your S0 is location of a robot, and the robot wants to go out of a building. Then, so the ultimate task is probably do something more. So ultimate task is plant a tree, plant some sapling in some garden. But for that, yeah, the first task it has to do is it has to go out of wherever in which building it is in. So at S0, its task becomes a much smaller task, which is going out of the building. So say in the real MDP, if it applies a policy at say S100, So S is position of the robot, right? So say is 100, the robot goes out of the building. Right. So till is 100, you can apply a policy. So if you I mean, S100 is random. When the robot will go out of the building, that is totally random because in between anything can happen. It can go in other direction and all. And it will also depend on the actions taken in that time. So if you divide this as the entire task as subtask and your first task is going out of the building, then at S100, your subtask is getting ended. And in all the time, can think, sorry, I shouldn't have written it above. So you can think this set of actions is 0. So what actually happens is that way you can think, right? And say the reward of that subtask comes only here, only after you go out of the room. So you'll get reward here. Say R1. Right. So you the way it helps in our understanding of hierarchical RL is you are at initial state. You have defined your subtask. You are at the initial state of your subtask, and you uh, encapsulate all the actions, possible actions you can take in that to complete the subtask as one action, and denote your termination state as another state or next state. Okay, so that is how you encapsulate everything one subtask as one transition of your state, and that comes after taking one action. Okay, now it will not be uh, correct if I call this as action, rather it's a policy. Okay, so here randomly it can the robot can encounter different state S1, S2, S3 and all. So basically it's a policy. A is a, let me write A and write that A is a policy. If you think in terms of the MDP, so the true MDP, it's a policy you are playing and it's taking you from initial state to terminal state. So ultimately, what is happening is you are at state S, you are taking action A, and after time tau, you are landing up in state S prime, right? And given a policy, say you're I'm now inside a building and I'm given a policy and I'm applying the policy to go out of this building. And if the policy is very bad, say I am now in second floor of the building, it will take me in the seventh floor and then again bring me down in the ground floor. So that's pretty bad policy to go out of the building, right? So here the reward that will I mean since the objective is achieved much later than what it should be when it should be. So this reward is also function of the time, because it's achieving it much later. And the transition, I mean, when it will reach the end state, that is also uh, a function of the time, right? So if the policy is good, it will reach much faster. And if a policy is bad, so here tau has more. Here S prime is basically something fixed that you have reached, right? Now under some policy, there could be you may not reach your goal state. Maybe some policy is asking me to just stay in my chair when the goal is to go out of the building. So that way tau will be infinity and the reward will be very bad, right? So that's how this MDP, this subtask, can be encapsulated in one transition of a SMDP, right? So is it now clear that why we use SMDP?
Yeah, actually, he had also mentioned it in the context of between our two actions, the world might have changed, the world itself might have changed. So that adds to the tau kind of situation.
Yes, but
Where,
that's not why. Yeah, that is true. But that's not why we use uh, this model in hierarchical array. The reason I'm trying to explain, the reason we use SMDP in hierarchical array is this. Okay, so that we can encapsulate one subtask in one transition of the SMDP.
okay, makes sense. So the tau represents that subtask.
Tau represent the time to
Time, matlab
complete.
time to complete the subtask. Yeah, sure.
Yes, yes. Okay, so let me search what next we can discuss.
So then why would you call it semi-Markov? It's still
Okay,
very
so
Markov, no? If tau is just okay. From S to S prime
so
to S double prime, it's kind of semi-Markov. That's it, is it? So what is the
well,
semi-Markov over here? Yeah.
I really don't know why semi word has come. What is the interpretation of that? But what I can tell you is uh, there is something called continuous time Markov chain. Okay, so in semi-Markov decision process, if you fix your policy, so in Markov decision process, if you fix your policy, you will get a Markov chain, right? Discrete time Markov chain.
Hmm.
Do you agree?
Yeah.
So in for semi-Markov decision process, if you fix your policy, you will get a continuous time Markov chain. So yeah, I understood your question, but why this semi word? Probably it's like say here you are taking an action. State is time t. You have taken an action. And say here. So what is Markov? Markov is probability is given sorry is t plus 1 given as t and as t minus 1 and so on. So this part doesn't matter. This p is t plus 1 then is t. Right. Now here say this is t plus t1. Okay. Now probability that is t plus t2 where t2 is greater than t1 t2 given is t plus t1 comma is uh, let me write this t plus s. No, s I should not
I
write.
think that
Sorry.
does that tau being a random variable makes it a semi-Markov process?
Yes, true. Yeah, true. Yeah, why that is the case that I'm trying to explain. So suggest me some. This tau is not. How should I write?
Tau is a
T.
random variable, no, in this case.
No, this tau is not the tau we are usually discussing in this context. So t plus okay. T prime t prime for all t prime less than equals to t plus t1. Okay. Now you know that you have taken action at time t, correct? So can you say this is equals to probability that is t plus t2? What is the largest t here? Is t plus t1, right? T prime, largest t prime is t plus t1, right? So can you write this? Is it true? You also have to know when you have taken the action. Otherwise, you cannot tell. So it's not equal. Is it making sense?
So essentially, you're saying in Markov property, it didn't matter as long as you were in that particular state. It didn't matter how you got there. In semi-Markov, you're saying
Rather, when you got there.
when you got there. In semi-Markov, you're saying because the reward is time dependent, it does matter.
No, reward is not coming in the picture. Sorry, reward is not some. Forget about reward. It's just the Markov chain. It's not Markov decision process.
At what time you got to that state is also a factor.
Yes. So, uh, yeah. So that's what exactly here. What is happening is you have taken action at time t. You have not taken any action or state has not changed till time. So here action, I'm bringing action here, but say there is no, I mean, the process is evolving without any action. That is called Markov chain or continuous Markov chain. So, this say the state is changed at this time t, and then at t plus t1, the state has not changed. Then you have progressed time further, and you're looking at t plus t2 and saying the probability of state at this time, given the probability of state at all the time here. So that you cannot tell based on the information you have here. ST plus T1 is not enough to encapsulate all the info till ST plus 1. Sorry, till T plus T1. To predict something about T plus T2, you need some more information. And the more information is basically at time T, when you started being at that state. Okay. So that's why it's same. Yeah, thanks for asking this question, because I also sort of revisited my basics and recalled why it is semi.
Okay, essentially you're saying that ST, that you require information of ST to know more about ST plus 2.
Not no more. So here you have a conditional probability, right? So what is Markov property? Markov property is this. Clearly. So this is Markov property. So what it is saying, the probability of at some, I mean the random variable ST plus 1, given all the states it has seen before, is equals to probability of the that state and just the first state of the past history. Past state, sorry, not first state, the latest state in the history, right? This is what is Markov property. So if we try to see the equivalent, okay, in this same Markov thing, I mean in continuous Markov chain or continuous time Markov chain. So this should happen. So here at ST plus T2, given ST prime, where T prime is less than equals to T plus T1. So by that same logic, if Markov property holds, then I mean that similar property holds, then this is will be equals to probability that ST plus of ST plus T2 given the latest state in that history. Okay, but that is not true. Why? Because the time when the state started, that is also
Oh, okay. So there is
variable.
some kind of lag between the action and when you get to kind of know about
Yes,
the state. They are not instantaneous, both actions and state kind of thing, like discrete time.
at ST
So
plus T1, you have some S. So this is random variable. When I'm writing subscript T, that is random variable, and this is your uh, some value. This is some value. ST plus T plus 1, sorry, ST plus T1 is taking some value, small s. Okay. But this is not sufficient to give this probability. This probability. Why? Because it's also required to know that when you have arrived at ST plus, I mean, this is T plus T1. You are at state S. When the state S is started, so state is, I mean, the process is at staying at state S for some time. That's why you are seeing it at T plus T1 from past. So when it started, when the process is from when the process is at state S. So that time is T. So this probability will actually be equals to PST plus T2 given ST prime for all T prime in this set T. Okay, so when it's that state is first seen, that is also uh, important.
Yeah.
Hello.
Yeah, cool.
Oh. So this options is nothing. I mean, so it's everything just encapsulating in mathematical form to use it for hierarchical array. Uh, so let me discuss it. So this SMDP is the main idea behind its options. So option has, you know, that there are initiation set. Oh, okay. So this paper, what I was talking about, the second paper that has some mistake also. However, okay, so there are three things. One is initiation or initial set from where you start the subtask, and then a policy, which is seeing the state and spitting out action. So here you can think about randomized policy, but I'm going with deterministic policy. So this you can call intra option state. And there is beta, which is a probability measure on the state space. This is probability which we so termination at state is. So if you consider this task again, a robot has to go out of a building. So what do you think will be the initiation set?
Sorry, come again.
So say you are considering this subtask of a robot going out of the building to achieve some bigger goal, to plant some tree. Okay. So what is the you consider the first subtask? What is the initiation set? So first the subtask is go out of the building site. So that will be the start state, right? So initiation set will be the entire all the positions inside the building. Okay. So why? Because whenever the robot will encounter that it's inside the building, that is the coordinate of his position is inside the building, then it will start executing the subtask that it has to go out of the building. Right. Then policy, I don't have much to discuss. So uh, say there is some policy. At every point, someone has designed which direction it has to go. And say beta, that is if say there is only one door in the building, right? So beta will be 1 if door state. So beta is s equals to door state 0 otherwise. Right. So for this task, you execute a policy and you go out of the uh, door out of the building, and then you have again another subtask. Say go to some say go to some other place, and then for that you have to see the initiation set will be now here. Say after coming out of the door, if there is only one door for the next task, say this is A0 start inside building, and then S1. S1 will be door of the building, right? And S3, if the hierarchy sets it to uh, go to the door, go to the gate of the campus, then this state will definitely be gate of the campus under any reasonable policy. Right. So this type of So this subtask, if you consider this subtask, this SMDP or this option, this is called point option. Such options. I mean, you have only one initiation set and your termination probability function is a indicator function. Okay. If that is the case, then we call it point option. So here, the intra-option policies, there could be a set of intra-option policies, right? Say pi, set of so whatever you have till now studied in RL, now you can apply those algorithms for learning these intra-option policies. So these are equivalent to action in SMDP, right? So intra-option policies and action in SMDP are same. That's one point to note. Action in SMDP is equivalent to intra-option policy. So the algorithms you have learned so far to learn best policy, that you can now learn to best action in SMDP. So these are equivalent problem, but for us, this because of hierarchies, hierarchical, you are dividing into subtasks. So your task is now very small, and there you can use RL algorithms. Right?
Yeah, so for each individual subtask, you can kind of learn a policy.
Yes, yes. And policy for option, policy over option is basically uh, uh, whenever you are at uh, those what is that called funnel states, where you have to uh, your subtask is starting. So there is another component. So this is intra-option policy, and there is another thing that is called policy for options. So that is, say, let me define it by phi. P, that is a map from initiation set, or let's write I, initiation set to pi, and pi here is intra-option policy. Policy set. So this is a policy and this is a policy. So this is a sort of inception of policies. Okay. So intra-option policies are policies, and then there is another policy which is called policy for options, which are seeing the initiations set and choosing a policy. Okay.
Okay, makes sense. Like, let's say you have to go to a destination, whether to take a car or like to walk. So
Yes.
within walking, you will have that intra-option policy, and then you'll have a hierarchy. On top of that, you'll have this policy of whether you walk or whether you take bus or something, that kind of thing.
Yes. Yes.
Okay.
Right. So I don't know what else to teach. So there is another topic which is hierarchical abstract machine. So that I have planned to discuss in the next week. Uh, but next week lecture will be next week Saturday will be Dashera. So I'll shift next week lecture to probably Monday morning. So Saturday will be the scheduled time, but I'll postpone it to next Monday. Is that okay? Monday morning?
Can you have it in the evening?
So Monday
Evening.
morning we have our official work, like it is engaged
Okay.
till 6. So
Okay.
Sunday,
Okay. I'll not keep in the office time. Then. I'll keep in the evening.
Will that be the
Sun.
last lecture, or
No, so
will be
there
one
will
more?
be another lecture which will basically sum up the. Yeah, that was my going to be my next question is there will be another lecture on 19th. I forgot the time. That will someone will post it. So on 19th, the lecture will try to cover all the topics or like broad ideas what we have learned and how like what are the relations between different things we have covered in the course. So there, if you have any specific topic to discuss with more emphasis, you can let me know.
So one question I would like to ask, I don't know if you know about it, but essentially, is the exam like an assignment only, bigger version of the assignment, or how, like multiple choice, or how does it work?
I heard it. I have never gave any NPTEL exam, so I heard it's multiple choice questions.
So similar to what we have in the assignments only we'll have, right?
I am not the best person to answer this because I
Okay,
really don't know. So I
okay, okay.
heard few years back that it's multiple choice questions, but you can ask in the
I'll ask.
forum.
I'll ask. No worries. Yeah, that's why I said I don't know if you know about it, but
Yeah.
it's
So
in change the pattern also. So mostly it is a choice based earlier, but last 2 exams I have seen they have given a fill in the blanks kind of stuff. So there you can compute, calculate, and it will. I
okay,
don't know
okay,
this.
okay. But do you have to take your own laptop, or they have the machines?
No, no. In
they
there,
have
there you have computer center that they organize it. Nothing
Okay,
you can take inside. Just the paper permission admission letter only. That's it.
okay, okay, okay. Makes sense.
yes. So about last lecture, if you have any specific topic to suggest, please suggest. I'll try to cover it.
I think what, if possible, what we can do is uh, we can we can revise everything at an intuitive level. The fundamentals of so basically we have had 12 weeks, no? So I guess if it's a 2 hour thing, 120 minutes. So if we basically say 10 minutes per week, right? So basically at a very high intuitive level, just to get the fundamentals right.
Yes,
Maybe
that's
not
the
take the.
same.
Is that
Yeah.
okay
Hello.
with you, Jitendra? Yeah.
Yes, same thing. I'm also expecting because throughout the lecture, lecture was great, but it is too much mathematical. Mathematical we can understand, but the intuition part is expect here.
And
As
just to
I
be able to connect the dots, actually, you know? So I think
yes,
to understand anything, it is very
is
important to
from
connect the dots.
courses are and terminologies are new. I am from electrical engineering background, so control system I get it. Last year I did the machine learning in NPTEL itself. So at this time so like Marco and all these I know the basic, but not in detail. So it will be better if you give me that intuition level approach. So best I
I think
can.
even I think one thing we can do, if it's possible for you, we can pick an example.
Suggest.
If we can pick an example, like a, whether it's a simulated example or a real world example, and we can discuss the 12 weeks in context of that example. That way it will be very concrete rather than abstract.
Yes.
So like you're saying, no, a hierarchical. So let's say go out of the building, or so start. I live in Mumbai, so start in Gateway of India, and then go to, let's say, Ghatkopar. That kind of a example, and then in that context, bring all this sort of weeks with that context in mind, so that it is kind of concrete. So not really care about the details, but care about the essence.
Okay. Nice, nice suggestion. Okay, I will try. I will try. Okay,
Okay, thank
great. Okay, so yeah, since we are at the towards the ending of the course, so if do any one of you like interested in doing research in reinforcement learning or
So I do research by
you.
default
Yeah,
actually.
I'm planning PhD in this same direction. Currently, I'm just from industry. I joined academia here. It, so next for the
here
PhD,
as
I'm computer and conventional. I'm well versed, but since things are coming, deep learning and that new, like you can say that reinforcement itself. So that the direction. This is just as a kick start for me. This course as I've taken as a like what say all this about. So I get the sense. That's the good part about it.
oh, nice, nice.
For me, actually, because I'm a solution architect, and so I basically was freelancing and then gonna go into an LLP now, where basically me and my partner, ours is an engineering solution providers, right? In automation in general. So
Oh,
every time we try to pick a project where there is a certain amount of R&D involved, we don't want to do something which is already done, right? So every time we want to pick a problem which has an element of what do you say, uh, at least some, like let's say there are 10 sub problems, at least two out of those 10 sub problems are unknowns. So there is some amount of element R&D in my have has been in my work in the industry for last 15 years, where the challenge has always been where we have to create something slightly different, whether it is on a much smaller hardware, or tweak to bring to basically an
competitive.
engineering level R&D,
Okay.
not algorithm, not go
Hmm.
in the core. What do you say? Uh, core,
So low
not dev.
compute,
Uh,
low compute algorithm might be one of the things you look at.
so let's say you have this, let's say Q learning, right? Or max Q algorithm. So not at a level where I'll be developing a max Q algorithm, but at a level where I'll be combining two or three of these algorithms to see which one works the best. So mostly an engineering level R&D, right?
Okay.
Uh, so that kind of stuff. Mostly not a theoretical kind of R&D,
Hmm.
but it
Okay.
does require sometimes to dive into theory, whether with to get to a solution. And you have to get into the assumptions of why something would work and why something would not work mainly. So I work in computer vision, right? So there is a fair little bit of R&D involved every time you have to develop a real life application.
Hmm. Great, great to hear. I mean, you're much more experienced than me. So nice.
No,
Can you
that's
tell
okay.
which was the, okay, okay. Go ahead,
So,
Nikhil.
sorry,
No, no, go ahead, go ahead. No, no, no.
I'm
I was
just
just saying.
asking which universities are actively working on this reinforcement learning in computer vision specifically. That direction. Can you,
So
if you
basically, what happens in computer vision usually is we just sense, right? But most of the real life problems don't end at sensing. You have to take some action, right? And even within the context of computer vision, what happens is there are a lot of thresholds, right? So there are these thresholds you set, a lot of magic numbers. So let's say you're running an algorithm, and 20 parameters are that which you would kind of heuristically derive, which make the algorithm work in a certain way. But you really don't know when you sell it to the customer where the customer is going to deploy it. So there is some. So at least that's the context which comes to my mind.
lots of lots of adaptivity element is involving.
Adaptivity. That's at least that's the context which is coming to my mind, there is so there is also in the recent case like that AlphaGo, they actually just use images to not AlphaGo, I don't know which video game. I think DeepMind did that. No, they just showed the images and the RL algorithm itself learned what needs to be done.
Yes, yes. So artery games are like that. So if you see this gym environment, I think I have shared with you earlier. So if you see the artery games, they just take the image as state. It's not like, yeah, now much more complicated things has come up, like uh, proper photographic image are being treated as states. Yeah, that's true.
Actually, last 10 year, I was also working on the background subtraction. Basically, Nikhil can relate that computer vision itself. But conventionally, I succeeded, but not in that sense. If environment is too much changing, so that's adaptivity
So,
doesn't work that much. Now, camera is
did you have
good.
did you have a stationary camera?
No, stationary camera, not like early. I go like I work in a lots variable now. Do you mean stationary camera means fixing a camera one
Yeah,
like?
fixed camera. Yeah.
No, actually, it's a more. I was wanted to make a more real closer to general solution. Like it should not constrain on anything on like NUI kind of stuff. If you aware of that, it is a
So,
more like you
yeah,
can.
yeah, yeah.
We should not constrain the environment. Like it could be like driving a car. So every time background is changing, right? It is not fixed, but the desired
Right.
object you want that is a foreground. The rest of the stuff you need to treat as a background.
Background,
So
right. So
some
that in that context
yes,
itself, the RL will be important, no, when the camera is moving, because
yes, yes.
imagine you are moving on a road
Then
as opposed to
motion
moving in a desert.
Sure.
There
Yes,
will be a
yeah.
two different scenarios as far as background subtraction goes, depending on
So
the kind
again,
of texture
Conventional
available.
work there. Yes, yeah.
yeah,
So
again, when the background is changing too fast, then I don't think RL can do anything. So there you have to do some data processing things, right?
No, no. So
I
imagine you can have a
like
system
keep
where
and
it can fail for the first 5 minutes. No,
yeah.
it can fail for
Before
the first 5 minutes and then adapt to the situation.
so those are the conventional. It was done Gaussian mixture model and all these are that learning. Those are for work. That's why I'm saying. If it, I work in a as a I started I put a startup there. So we have to work in a real world scenario, no product when you develop, as you said, industry. Academia, it's fine. You can publish paper and make a paper, but in real world you can't. Customer you cannot say, na, explain the technology. They wanted to perform very well. That they so a little bit ghost flowing is there. Like I was designing a, like you can make any virtual keyboard of, yeah, or mouse like no hardware is needed. That direction I'm working. Like everything should be learned by camera. Like how we make most of the decision like with our eyes and do the stuff. So that direction I was working. So okay, that's so the memory concept I wanted to introduce where I learn as a queue function what you are like learning that these terminologies are there, but I was taking earlier as a memory some prior what information regarding the like as a human we do, right? So not only the current frame is helpful, the scenario, lots of prior information also makes. And one more challenge was there, like camera was earlier there like 2003 or 6 right? There was not much good cameras. Like processor was sorry. Nowadays we get in mobile very good quality of camera, like more visual, more megapixels, so you can like better filtering you can do. Earlier in filters, whatever we are using, either it make too slow, like beyond human sensing. I wanted to perform it, so it will make sense. Like in a driving case, when it is a speed like 60x, nowadays you can record the 4K in a 60 fps. So there, those stuff will work. So let's see. I will incorporate this reinforcement. Like that's why I'm asking which university or actively person for faculties who are working exactly on
Yes, so
reinforcement computer vision.
yes,
So
so
that
I am in yeah, I am in Indian Institute of Science. So here the reinforcement learning community is quite big. So uh, yeah, I can send you some names.
yes,
But
not
most
now.
of
Yes,
them are most
whenever
of them are interested in theoretical side. Yeah, few are there who works in application side as well.
Okay.
So for computer vision and reinforcement learning, this two someone, yeah. So yeah. So if you see RBC CPS, there is a separate department for cyber physical system. There are some professors who works on robotics, and now they're trying to incorporate lidar sensor or yeah camera in their algorithms.
So even in your context, no, Jitendra, where you said that you are picking Gaussian mixture models or whatnot, all of this you are picking heuristically, no? Matlab you were hand picking it. You are making those decisions, like based on
Quite
your.
centralized, like it is okay, but we develop also successfully some of the like large piano we have built, where like customer, like person who is playing it does not have any constraint. Like six and that time, if you know, MIT have published some advertisement. They put some finger on color and then they try to demonstrate the NUI stuff, natural user interface. Have you seen that TED Talks that time 2006 around it was?
No, no, I
Uh,
have checked it out. Natural user interface.
So that time it was just, but in our case, no any kind of assumption. Like even even now Google also, if you see the background subtraction, they get not that robust. Like if you see Google Meet or something, the background removal front and the near a ear or some, you will see some cutouts, right? If it so that but we succeeded that much, means you can have a better cutout of foreground as compared to what current existing are. But as I said, if environment are totally changing, like in case of driving, so there we have to work there.
So
So there, let step like I wanted to integrate. So that's why I'm exploring this enforcement. Some of the idea I got, I need to test them. So it will take a time. But
So voice and touch are themselves NUI, no? Natural user interface.
that
No?
time touch was not there. That is the more my whole well, work is to generate a virtual touch in any condition. So that is my whole solo well, work is there.
Okay, okay, okay. But virtual touch is fundamentally not natural user interface.
Not natural. That's why it's interesting
Okay.
also, because I was
Hmm.
again using a single camera. Everybody other one using stereo camera, you can get the depth. But I was one more. I got a eye hemorrhage, so that time I was only able to see through my one eye. But still, I was able to make decisions. So there, I get the idea that we can do it with the one single camera also. So that yes, certainly
No,
depth.
no, no. What I'm saying is that virtual touch, no, what you're saying virtual, that
Yes, what
itself is not a natural user interface, no? Fundamentally speaking, that's an artificial user
we
interface.
can get the info that that's yes, but we can get most of the activities like you are doing, uh, and most of the tasks are done. So that what's a harm? Okay, yes, that
Okay.
is certainly what will touch. If you get a like projection, somewhere it get fail, but most of the tasks it do better. Like there is the whole concept actually. Hmm.
okay, one
What
question.
is your
My
research area, Avi? What is your
Hello.
research area?
oh, yeah. Before that, I want to ask one question to Jitendra. So you're doing this foreground extraction, right? So maybe it's unrelated, but what is the motivation of doing that foreground extraction?
Without section like your hand or whatever, you need to first separate from the background, right? And what action your finger points are doing, that action can be mapped with the whatever you wanted to do. Like keyboard, suppose we develop a virtual mouse and keyboard. Like any surface you can make as a like a keyboard or any app. You don't need to learn specifically like hard coded key. If you press this one, then you do this. No need to do that. It is a very general. So whatever
Yes.
application like touch nowadays, mobile have touch sensor. So we can make any surface as a touch. That's the whole task here we are doing. It is
Nice.
So
independent of.
fundamentally, the foreground extraction is just to detect change,
Yes, no
right?
change, but
So
it is a
foreground is the change.
yes, yes. But in the if you do practical enough, like shadowing also there, lots of lighting is changing. So
The leaves move,
it is
trees
not
move with the wind. It should
yes.
not be captured as foreground, right?
Uh,
But I was of another point of view. I would argue that if the trees move, might as well show it as a foreground only because that might be something actually.
no,
So
so
there
but
is another
that,
way of looking at it.
unnecessary process there. That's a there is dynamic foreground subtraction is important. Like a little bit changes they apply that Bayesian network there. Sorry, Bayesian based solution are there, but it is not much like it is a better solution, but not a perfectly solving it. Like
Yeah,
hard
I
shadow.
also actually implemented the same thing on a drone. So I used to work for a drone company, and I applied it in the context of moving target indicator. So basically, whatever is so everything is moving. No, in a drone, the camera is always moving. So you have to detect the moving parts, right? So
Yes.
foreground is what is moving. So I
Yes.
applied it in that context, right? So it
Ah,
was the challenge comes from
lots of
being
foreground.
the moving camera
Yes.
for the challenge comes from for a moving camera, everything is moving, right? So within the moving, how do you detect the moving?
For that you can
That
just
was
modify your motion because you're knowing your speed, no? So you can like that motion blur motion that vector you can subtract and you can model
yeah,
that
but
one.
essentially, if you have to have a dense model, you have to have a background subtraction. So right, so you will
Yeah.
not know even with the motion model what has moved and what has not, right? So everything has moved, right? Technically in the camera.
No, but
So
in your own case, you know the speed, no? Acceleration, you are
it doesn't
relative.
matter even if you know the speed because everything is at different depth. No, you will have artifacts. So let's say there is a building and there is a ground,
That
right?
can
They
be
move very differently for a
of
camera.
yes.
So both of there is a relative motion when it comes to perspective. So
Perspective
you have,
are there. We do in the camera model, right? And projection matrix are there. So there these problems can be handled. Until unless it is not very blur, like motion are very it's too fast, so it get blur. That is a challenging part again in doing real. But if
no,
you
no,
are
it is still challenging. Whether the motion is fast or not, it is still challenging. It's fundamentally challenging because, like when your camera moves, no, a building will move in perspective. A picture of because it has depth. If you
corrected,
assume
that is
everything as if you assume everything as an infinity, no, then you can do it. Then the image basically there is no, but it doesn't matter. You can just there is a simple projection matrix. But if there is depth involved, then everything moves differently. So different depths will move differently when you move the camera. It's a simple thing, your hand in front of your eyes and hand like a thing very far away.
mhm,
The hand motion is much large in front of your eyes. If something very
mhm,
far, it has to move a lot to create that kind of motion.
mhm.
So
So the depth itself is
So
a
like
challenge. Yeah.
panorama we create, right? We rotate our cameras, right? And we can stitch that them panoramic view if you are knowing it the
Yeah,
already.
if the camera is if the camera is rotating, right? If the camera is translating, then you will have perspective.
Huh.
Only pure rotation you can stitch. You cannot stitch
So
translation.
there are you will get many papers in that. Like earlier, na there was 3D scanning with the single camera people are doing, and like
Hmm.
that time not that Google was so much like they use that lidar one, but that I'm talking about around 2000. Yes, 4 or 5. You will get many papers on the depth detection through shadowing and this perspective based. You will get it.
No, no,
That's
true,
not a
true. What I'm saying is there is no matrix which can take you when there is rotation and translation from one image to the other.
your
If there
camera
is
model.
pure rotation only, you will can have a matrix which can take you from one image to the other. So there will
No, you
be because of
it
this.
handle translated can be handled. It's not big deal. That's the whole camera model is
No,
no?
it cannot. It's not. It cannot handle. It's fundamentally because there is no matrix which can take you from one image to other if there is a translation, right? Only if the then so
Optical flow
basically
can
translation creates the perspective.
mm,
So
uh,
the
I
homography you're talking about homography, no? It has to be pure rotation.
think it's a mapping, but that could be used. But yes, optical flow. There are techniques I'm talking about. You can do it. You can get many paper, and it is
Only if the object
also.
is at infinity or it is a pure rotation. You cannot have basically depth involved and have a single matrix which can solve your problem. Anyways, ठीक है, cool.
There are techniques by motion of the camera you can detect the depth. That's I'm telling. So like in pigeon or why they if you in robotics we also study like pigeon when you see their head are keep on moving. Why? Because they the depth sense by you moving their head like
Yeah, but
camera.
I agree with you. But what I'm saying is you cannot simultaneously detect whether it is depth or somebody has actually moved
That
with
can
a
be done
single image.
with native version because you know the your pixel now. Now do you are you aware like when you click any image, you can tell the camera model also how this can be done.
Sorry. So if you have multiple images, no, you either assume that something. So you basically camera does a
Camera
stationary world assumption.
camera calibration is not quite like it is a well perfect technique. There's no ambiguity in that. Like nowadays, more information are there. You can tell the quite accuracy, like even in 1 inch depth. Yeah. Definitely, if it is very far, the error will be more. But you can do like this is not unsolvable problem. It is a solvable.
Cool, cool.
Okay.
Yeah, it's a solve. I mean, so it's like it requires a higher level logic where you first build a world, assuming that everything is stationary, and remove the outlier, which is kind of
The camera
not
model is
doesn't
like
respect that world.
no,
There is no like a one shot thing which you can do over here. Anyway,
it
so that's cool.
will follow the physics. Physics one whatever natural phenomena that is follow then fine. But things like robotics, like human are doing some semantic things are there. Sorry, syntax. Yes, like meaningful meaning abstraction is there. That is a difficult part. But something is followed by natural physical law, no? That we can solve it. That's not a much big deal.
True.
So,
Okay.
very nice discussion. But here,
Very simple thing I'll tell you,
electric.
Avi. Like matching, no? Matching, just matching, which is the fundamental of most computer vision algorithms, right?
Yes.
So
Yes.
that depends on thresholds, which you set manually,
No,
right?
no, that is a very classical and primitive level you are talking. Nowadays, how we do matching by using shift surf was the conventional which have
It
performed
doesn't
well.
matter. It doesn't matter. You still have a threshold. Whatever you do, you'll have a threshold.
Adopt everything
Unless
have
you have a
at some point. Whenever you make a decision, you have to use the some thresholding, right?
but that decision itself can improve, no? That is the
So this
RL part.
adaptive filters we generally electrical the signal processing person we use the adaptive one. So that gives the every time not a hard coded like we set it. It adopts as per the
It is hard coded. It is hard coded. You have to whenever so you cannot have the same algorithm behave differently on two
have to
occasions. So
make
it is
it
hard
like
coded.
in deep learning or what machine learning, we have to map 0 to 1. Like we use the Bayesian probability, and there you can.
Exactly. Even if you use it, you have the machine learning, the supervised learning framework. You cannot have the same algorithm behave differently on two occasions. So RL gives you that opportunity to make it behave differently on two occasions by learning, right?
Hmm,
You cannot,
hmm.
just deep learning doesn't mean that it is not hard coded. It's still hard coded. It is behaving the exact same way every time you
That
show them the.
make a challenge. That's a whole work, like decision making. Like in background program subtraction, I was struggling. Like when there is a hard shadow is too hard, or shadow is like, or some color is a person is wearing it the same exactly as the foreground. There you get a difficulty in to get a make a decision, right? Because the thresholding is tough there.
True. So that's what I was initially started with. Even the matching problem, no. Even if you use the most sophisticated matching technique, even if you use a deep learning matching technique, it is still
Hmm.
hard coded.
Yes,
You
definitely.
cannot
It is
change it.
not fully solved. That's why research is there. It is a keep on.
So
It's not the technique. That time when I was actually graduate from IIT Kanpur, so that there we were working. Machine learning was there also, but at that time camera processor was not that much good. Well, we don't have a good setup there, but still it was making lots of mistakes. But 2013 paper like that's deep learning one come they really perform well. But still, for my application, it was not fruitful because we want a human sensing beyond. Like when you touch it, so immediately music are created, so it would be very fast. So that much time in real time making this the learning one, still they are away. Means to doing the real data. But now processor and cameras have improved quite well. So hoping I wanted to just my whole whatever I have developed to integrate this new concept. So let's see how it's performing there.
Yeah, actually,
So
I am very excited. So I really like. That's why I try to attend every lecture sincerely.
okay.
Is because I'm hoping I can use this.
Yes.
I am excited about like being able to adapt. That's my whole thing. Like I
So,
love that idea. That's why I thought RL is the best way to do it.
Yes. Yes. Yes.
so if you want something to theory, then you can also look at this. Yeah, there are in RL you can find algorithms with non-stationary environments. That's true. And there is another thing I think we have already discussed sometime. Uh, there is something called change point detection, where you actually able to detect that where you need to learn, you need to start learning because of change of your environment.
Yeah.
So yeah, those things you can look.
Cool. So I really like that when he started with the continuous function, no? Function approximation. I think that is very probably most relative to even discrete setting is not that bad actually to just start out with, but that function approximation thing seems very promising for my area.
Sure.
Actually, I
So
also worked in
function
navigation.
Hmm. Function approximation is something which is used by the industry because of neural network is a function approximator, right? That's
True.
the main thing we use.
So neural network is just a tool. I'm just saying that general idea of being able to like say about the state space with parameters. That whole
Yes.
parameterization process that is pretty exciting actually.
Yeah, I'm
Uh,
saying that that is the best thing that uh, theory or academia could give the industry. Function
yeah,
approximation.
cool. I am very excited. So I really look forward to like being able to start using this actually. And just knowing this is actually one thing. It is itself is not bad. Just knowing it because you can have conversations now, like whether it is in hiring or whatnot. But just being able to use it and solve problems is also very exciting.
Sure.
Cool.
Like currently there is a one more problem which I'm working, like taking attendance, like you get the many paper of face detection, multi-face detection, but you can still see there whatever the example last bench person get left. So there again we can use, like as a human we are able to say that ki, there is something, some person is there. So still there is some like due to resolution it get failed, but still as a human brain we are able to estimate it. Some memory part is there, right? So that could be integrated here. Let's see how it's performing. Okay.
Nice.
Yeah, but the
But
whole idea, no, actually the multi-arm bandit idea, where
Yes.
what is the fastest way to learn something, you know? So that whole idea was exciting because in the end you want to learn something optimally, and then you have this value function and policy gradient methods. So actually, I started understanding the course somewhere halfway into the course. I was pretty actually, I was very, it was very vague for me at the start, but when I started getting a glimpse of like the fundamental, then I started enjoying it much more. As to the whole connection from multi-arm bandits to uh, the how to do it, right? So that it was very vague at the start, just learning the MDP and everything, but not, then it started making sense.
nice.
Nikhil, you work in industry or what? Where?
So I actually, so I was in a drone company until 2 years ago. Then I just started out on my own as a freelancer, and now I'm this year I'm doing an LLP. So I have a partnership with a friend, and basically going into this automation industry, any kind of engineering automation.
Okay.
That's what we are targeting,
Okay.
whether it's in the defense sector or in the commercial sector.
Okay.
So I've been in the defense sector for 6 years with Idea Force. I was there. Uh, so from there, yeah. So automation is where I love any kind of automation, right? That is the exciting part for me. And just to not just do it for the sake of it, understand the energy requirements and have a holistic view on the solution also, right?
Okay.
Whether you go with the big compute power or a small is enough, that kind of thing. Because in the end, people don't buy expensive things.
Yes. Yes. Okay.
So,
Cool. Okay, so to end the tutorial session.
Yes.
okay, good.
Thank you, Avik and Nikhil.
Yeah.
Thank you
Thank
so
you
much
both
for
of
the
you.
visits. Yeah.